Welcome to the Spooky Action at a Distance television show. I'm Kyle Finley, and today's topic will be the electric universe theory as presented by Keene Tiedemann over here. How's it going?
Pretty good.
Just pretty good, not great?
Yeah, we could call it great because I'm here with you.
And you're going to be an expert in this field, right?
You bet.
So what we're going to start off with is how do you get interested into this topic?
I got interested in the topic. One of my interests from the time I was a little kid was the topic of UFOs.
Yeah, which we're both interested in.
Right.
Many people on the show happen to be in the UFO club. You know,
Yeah.
what a coincidence.
Yeah, and I sat there and I've heard stories from many people about seeing things. I've never seen anything, I've never experienced anything, and I was wondering what this was all about, so I joined MUFON and became a field investigator.
Mm-hmm.
Did that for a couple of years, worked in the database, did a lot of studying on the subject, and I could not find anything that really made me a believer. It all seemed anecdotal to me, and so
it basically is all anecdotal. You know,
Yeah.
everybody's like, you know, a lot of people are like, you have to have an experience in order. You know, there's that fine line. Unless you have that experience, you're not going to be in, you know, the field and stuff.
Yeah, you're not in the club. Yeah.
But I'm in the same boat as you are. I've never really had an experience
Right.
either. So.
And so I sat there and I said, well, what could be causing people to be seeing these things? And so I started looking at astronomical information and cosmology, and I came across something called the electric universe theory. And that absolutely fascinated me because I've always had a problem with the standard cosmology's idea of
you don't like the standard model where everything's mathematically sound. You know, you get basically a million variables, and if they all fit together, that explains the universe. You know.
And it would if it did, but the problem is that the more we observe in the universe, the more questions there are, and they seem to come up with theories of, well, the universe is expanding. Where's all this energy coming from? We don't know. So
we're going to throw in dark energy.
Yeah, let's postulate dark energy and dark matter as something that's helping the universe expand. We've never seen it. We don't know what it is, and it's dark, so you can't prove that it's not there because you can't see it. But we can make a mathematical model that says it must be true, and then it's true.
Yeah.
Well, okay, maybe.
Not only that, but it's 97% of the universe. It's
right.
More than anything we've ever observed in our entire lifetime, and it answers everything.
Right, and the problem is that you can't verify this scientifically. You can't do any scientific experiments to develop dark energy and dark matter because they don't even know what the heck it is. It's a postulate, you know. When I started looking at the electric universe theory, I was sitting there thinking, electric plasma, things like that, plasma balls, you know, people are seeing...
Which does tie in the ufology, because a lot of people see these plasma balls out of nowhere, and they're like, you know, what was that? Was that a UFO? It looks like, you know, it's unidentified, they don't know what it is.
And I'm sitting there thinking, well, you know, maybe this is what it is. They had the earthquakes, and they produce the ground lightning balls. You've got the lightning balls from the thunderstorms and things like that. Maybe that's what people are seeing. But then they're talking about hard, you know, crafts and being abducted and all this stuff.
Taken physically from one place to another,
Right.
so that wouldn't be a cause from a naturally occurring plasma ball.
Right. But in the process of trying to wrap my head around this experience that people are having, again, I came across the electric universe theory, and it just fascinated me because they seem to answer a lot of the questions that standard cosmology can't. And it all starts with our concept of life here and who we are, and this is what we understand. Our reality is what we understand, so we have, throughout human history, expanded that to the universe. And for the longest time, there were 3 states of matter that we understood: solids, liquids, and gases.
Yes, not elements.
And they do form, you know, when it comes down to it, you know, all the elements are solids.
Yeah, all the
and
elements,
gases.
they can be in the 3 different states of matter. Well, 4 different now, you know.
Now,
basically.
right. And then comes along Sir Isaac Newton, and he explains the law of gravity. And so,
well, I don't know if he explains it.
Well, he mathematically wrote it out and said, here's what it is.
He explains,
how it works, not
Yeah.
what it is. Nobody knows exactly what it is, right? But he gave us an equation to describe it.
I always like to make the distinction there.
And that's a good distinction to make. So you have humanity. We've had the three forms of matter, and we have gravity. And you get into the 20th century, and Einstein comes up with the theory of relativity, and people took that and they developed quantum theory, and gravity became the dominant power in the universe. It explains supposedly how solar systems form through disk accretion into a star and planets around the star and all that kind of stuff. And that's the way we've understood cosmology.
Other than all the dark matter and dark energy that we talked about.
Yeah, which all came out of the space age, because as we sent the satellites up and we went further and further out into the solar system, and we took the telescopes up and we got beyond the atmosphere and we saw strange things happening out there, we were saying, what the heck is this? You know? And so they were trying to use gravity as the constant in the universe and forming their theories of why things are happening around that. Well, in the 20th century, we found another state of matter, and that is the electric plasma. The first three states of matter are basically electrons, protons in an electrically stable process. They come to form the elements, they come to form molecules, elements, and rocks and gas and uranium. And
you got the solid where everything's together, you got the liquid where everything moves a little bit more, and then gas where everything's free to fill up any container, and then plasma is supposed to be the state after that. Once you heat it up to a certain point, the electrons become free to move, and it's a whole other
Exactly, yeah, you have free electrons, free protons, and they float in magnetic fields. And Christian Birkeland was one of the primary founders of this idea, because back at the turn of the 20th century, he was a plasma physicist, and he was very interested in the aurora borealis, and he spent years taking his students out for field trips to study what this was, what is it, where is it coming from, and he developed the theory that the aurora borealis was actually energy coming from the sun, coming into the earth and causing the lights that you see. And he was scoffed for that. That couldn't be.
Of course not. If other people haven't discovered it, surely this guy doesn't know what he's talking about.
And it turns out he was right. And when we got satellites up into the Van Allen belt and around the Earth, we found out we've got a magnetosphere, which is a plasma sheath around the Earth that protects us from the radiation of space, not only from the sun, but from cosmic rays.
Yeah.
And we discovered that the sun is emitting a solar wind that goes into space, and that when those particles leave the sun, further they get away from the sun, the faster they go. Well, why would they be accelerating as they leave the sun? The electric universe theory purports that the sun is a positive anode. The planets, as in their orbits, are negative cathodes. The further you get away from the sun, the more negative the potential of the planet. And so that they draw the energy, the solar wind, and they speed it up because the solar wind comes out in a positive state and it's rushing towards the negative state to try to equalize itself.
Oh, so they're basically attracting a lot of the stuff towards them. Okay.
And another fascinating thing about the electric universe theory is they directly contradict the standard model of the sun. We understand the sun as a fusion reactor. Heat is produced in the core of the sun. It comes out of the sun and radiates into space.
Yeah.
It gets mixed up with very complex magnetic waves that they say make the interior look cooler than the exterior, and because the surface of the sun is 6,000 degrees I forget what it is, Celsius, but then the
if we had Dave here, he would be able to rattle off these.
But the corona is millions of degrees, and that's the outer atmosphere of the sun. Well, why is it cooler on the inside than the outside? The standard model
heat rises, obviously, so
standard
it's
model
cooler.
Says, it's magnetism, complex magnetic fields, and the electric universe theory states that no, the sun is not a fusion reactor. The sun and all the stars and all the galaxies and everything out there, they get their energy externally. They get it through the electric plasma, and they believe that the electric plasma in the universe constitutes that 97% of energy that we don't know about.
This doesn't sound like a switch around, right? They're not just taking dark energy and being like, well, this is now plasma, and that's where all the energy is coming from.
Well, you're talking about a layman who's just getting into the subject, and you're talking about electrical engineers and plasma engineers who are doing experiments at places like Lawrence Livermore Laboratory to produce in the laboratory what they're seeing in the universe.
There's a lot of scientific research going into these theories. It's not just some guy spouting off one of his crazy theories.
Exactly, and the fact that they can back it up by laboratory experiments, which standard cosmology can't do.
Yeah. Same for string theory. Just for the record, I'm throwing that out there. String theory, they can't back. It's kind of the same thing that you're talking about the standard model, but I like the standard model a little bit more than string theory. String theory was kind of made up by some, just scientists in the university doing what you're talking about, nothing but math. They would come out, huge art board things, just equations wrote all the way down, you flip through them. I had a whole book about, it's all math, no experimentation, which that's not science, in my opinion. I mean, I don't see how they get away with it.
Yeah, and some things in cosmology are reproducible. So I'm not saying that nothing is. My big problem with the two is that it seems like when they're talking in public, they're butting heads, they're fighting each other. There are two paradigms here, the standard paradigm of cosmology and the electric universe theory. And every time the electric universe guys are trying to describe what they're seeing, what they're finding in their experimental labs and stuff like that, and verifying this stuff, they start bashing the cosmologists, saying, well, they won't listen to us, and they're stuck in their paradigm. And I think it's true, but I don't think telling them that is bringing us towards a unity. I think there's correct information in both of them, and that what the two sides really need to do is to come together.
Work together, but nobody likes working together.
It's hard to do when you've developed your academic reputation on a theory. And as a matter of fact, Halton Arp, a famous astronomer, basically lost his standing in the American universities because he cataloged a series of strange galaxies. And he wrote a paper and...
what do you mean by strange galaxies?
Galaxies that seem to be connected to quasars. And quasars are the most brightest, most distant things in the universe. And he found that by looking at radio telescope imagery and even other spectrum imagery, he found nebula, or galaxies, big circular galaxies with tails that reached out to a quasar. Well, that can't be, because the quasars are way too far away. They can't be connected. But he said, here, look at this. Look at the magnetic lines. Look at the data. These two things are connected. How can that quasar be so far away? And he wrote a paper, and I forget who he submitted it to, but the head of the institution wrote on the paper, "This is beyond my imagination." Sent it back to his boss, and his boss said, "Can't get it published." And he refused to just give up on it and go the standard route, toe the standard line, and wound up working in Germany, doing astronomical observations from there and recording his findings. And what he has postulated is that quasars are not as far away as the edge of the universe. quasars are young galaxies. Galaxies spit out new galaxies. And you see the connection of the old galaxy to the new galaxy as it's being spat out.
So then the quasar would be there and it'd be spitting out that new universe.
No, the galaxy is spitting out the quote, the quasar, unquote. The quasar isn't what you think it is. The quasar is actually a young galaxy coming out of an old galaxy. And it's not as far away as you think, because redshift doesn't necessarily have to equate to the Doppler shift. The further away something is, the redder it is. Well, that's true in the spectrum, but the redshift can also be a sign of age. Younger galaxies are much more energetic. They're going to be in the redshift because they've got a ton more energy than the old galaxies do. And since these things are connected, he said these aren't quasars. These are young galaxies coming out of old galaxies. And again, the cosmologists couldn't wrap their head around it. They said, no, it can't be. But it does fit in the electrical universe paradigm.
So how does that work out exactly?
Well, it expands into the idea that
basically there's at least another effect other than gravity is what I'm getting.
Okay, and that's a good point, because if you put a metal ball on the table, it's held down by the force of gravity that keeps it on the earth. If you take one of those old magnet horseshoes, you come over here, you go like this, click, you can pull it off the table and usurp gravity.
Because the electromagnetic force is greater than gravity.
The electric force is 100 billion times greater than the gravitational force.
Sure, that's the right amount of billions?
Yeah, I rehearsed that last night.
Okay.
Yeah, it's that many times greater than the gravitational force. With the understanding that the universe is actually full of electric plasma, the predominant power in the universe is going to be the electric force, not the gravitational force.
Yeah.
Now, another thing that comes with electric theory is that everything is interconnected. Like I said, the sun is getting its energy from the galaxies. The galaxies transmit their energy to each other. Everything connects to everything else electrically.
You sound like a Buddhist right now. I'm just saying, everything's part of everything, you know?
And it's now going down to...
Are we talking about consciousness?
Actually, yes, they are going that far. They're going down to the biological level. They're going to the atomic and subatomic level, and they are even talking about consciousness. And again, you're going way. I'm an electronic technologist by trade and electrical and educational background. So
electricity is your thing.
That's way, and that's why I was able to wrap my head around this, because this is something I understand, and it makes sense, and it answers holes in standard cosmological theory. Like the pulsar. The pulsar is supposed to be a spinning neutron star, and it spins so fast that you get pulses of light in milliseconds. Nothing, first of all, neutrons cannot pack to that density. Nuclear theory says neutrons cannot pack to that density. It's impossible.
But everything's possible with gravity, right?
If gravity was that strong a force, then I think we'd be sitting here like pancakes rather than like we are. But the electric universe theory says what you're probably looking at is binary stars acting as capacitors. The charge transfers from one star to the other, and that electric charge transfer can happen in milliseconds. They can be slapping that electricity back and forth and creating the radio waves and the light waves that you see in milliseconds. And it doesn't. You don't have to involve strange equations with neutrons that don't do things that neutrons can't do. It can be proven in the laboratory electrically. I mean, we have oscillators that oscillate. You take a couple of capacitors, a resistor, and some electricity, and put them in there, and you oscillate frequencies at milliseconds and things like that. These can be demonstrated in the laboratory, and that is primary importance to the electric universe theorists, because if you can't, like I said, we lost our way. We lost our way when we stopped demonstrating what we thought we were seeing in the laboratory.
And this came up with answers for,
Right.
Okay.
And most of these answers come out of mathematical models. And you can use mathematical models to explain things that do exist. You can explain things that don't exist, because math is a language.
Especially when it comes to like statistics and stuff, and you're looking at correlation between events, it's like, well, just because they correlate doesn't mean that, necessarily affect each other, It could be
because you can prove something mathematically doesn't necessarily mean that it's true. And a lot of people I've talked to on the internet about electric universe theory who hate it say, no, it's proven. It's been proven mathematically. It's proven. That's it.
Mathematical proof.
Yeah.
End of story.
Yeah. and they believe that. They take that for fact. But now mathematical design leads to theory, leads to possible explanations, not the truth, not the answer, but a possible explanation for what's
it's not
going
really
on.
empirical proof, which
Right.
is where you get the experiments to, bring back, be like, well, if it's really that way, you should be able to reproduce it.
And that's really what the electric universe people want to do. They want to bring the science of cosmology back to an empirical state. Develop what you're seeing out there, prove it. And they've been able to do that with the plasmas. You know those plasma balls you get at Spencer's? You put your hand on it and it creates the sparks.
Oh
around
yeah, I
your
got a
hand
few
and
of
stuff
those.
like that.
I should bring them on the show.
If you put your hand on there and you look, you'll see that as the sparks come out, they fork like this. If you slowed the image down to like on a high-speed camera, you'll find out that those are actually two currents and they twist around each other. Those are Birkeland currents, named after Christian Birkeland, who was the father of plasma science and the theories that have expounded into the electric universe. Those Birkeland currents exist throughout the universe. Plasma exists in 3 states. Dark mode, you can't see it because electrons and protons are far enough apart that there's the density is very small.
Dark energy.
Bang. There you go.
I don't know.
Now, seriously, I mean, in dark mode, you don't see plasma. But we found out that plasma is out there all over the place. It also, the next mode is the glow mode. That's fire. You light a fire on a match, you're holding a plasma. That's glow mode. Arc mode is the other form, and that is lightning. Lightning is a plasma in arc mode. Now, you can take pictures of star nurseries and nebulas, and what you see is you see strings of stars forming along. It's like a string of pearls, and you can see the Birkeland currents that twist through all those stars.
So they're like connected.
They're electrically connected. In arc mode, you can see those. The sun is electrically connected to other stars in the galaxy, and they're all connected in a plasma in dark mode because the density isn't bright enough for us to see. We're not in a star nursery. We're not being created.
But it's still plasma,
right? Right. And the Birkeland currents come in at the north and south poles of the sun. They heat the sun from the outside, and the sun cools as you get to the interior. Every planet and the sun, they all have magnetospheres. They have these
and so are they all kind of
around
connected in the same way, just maybe in a lesser
It can
amount?
all be explained electrically.
All right, so okay, so this is plasma that's actually connecting the stars, right? This dark
Right.
plasma. So how are we able to read it? How are we able? Can we look at the sun and just be like, well, here you can see the dark plasma at the top where it's hotter, right? Like.
Well, actually, it's not a matter of heat so much as just electrical energy transfer. When you're talking about hot, that's one of the things that makes us suspect that the current is coming from the outside,
Okay,
because
so-
the corona is 1,000,000 degrees,
Yeah,
the surface is 6,000 degrees, and you go into the sunspots, it's even cooler.
So we should be able to see some kind of, like if it's connected to another star, there should be a tail coming off of it going to the other star, right? Of electrons.
If it was in glow mode, if the
Well, that's to
plasma
see,
was in glow mode.
visually, but I mean, what if we put a satellite out there and measure the electrons?
And that's what we need to do.
Okay.
But
that's just something we haven't got to yet.
A problem we have in sending satellites out into space is we're trying to answer questions of the standard cosmological model.
Yeah.
We're not thinking of the universe electrically. So we want to go to.
I guess technically we wouldn't have to do it on the sun. If it's connected to the planets as well, we could do it on our own planet, right? And then just put a satellite out there, see if there's something there that the standard model doesn't explain, and then be like, bam, electric universe theory.
Yeah, and I think there probably are a lot of things out there that the standard model doesn't explain. I
mean, you just add another variable and you tweak it a little bit, and bam, it's good to go.
Yeah. Yeah. But that's, to me, that's making a lot more sense. It's answering a lot more of the questions.
Okay, so we're getting down to the last minute here. I want to jump really quick into the area you're not familiar with, the consciousness, because we were talking about, I don't know if you listened too much about it, but the entangled particles, how people are connected like that. Does this somehow explain entangled particles, maybe? Does this?
Oh yeah, when you go to the subatomic level, the atomic model says you've got electrons and protons, and you get down to a point where the molecules don't break down any further.
Yeah, basically the quarks and everything.
Well,
but anyways, that's coming to the end of the show, and so I'm going to have to thank you for being here as a guest, of course, and thanks everybody for watching, and I hope you tune in next week to Spooky Action at a Distance television show.